Hi everyone, so I'll be filming the week 1 physics quiz for week 6 physics quiz, sorry. Question 1, but first, before I start with question 1, I have a list of physics formulas here. Some formulas aren't in this list because I just wrote whatever I could remember بصراحة. But the ones that they will mostly ask for is in this. The ones that aren't in this, you see me apply along the quiz, so I'll just start with question 1 so I can get started. Which statements I throw about E? GPE is always given with the respect to reference. You'll see it in a later question, but you can't have gravitational potential energy without a reference, and no, it includes GPE is mgh. So if GPE is mgh, you need height. Height isn't to nothing. Height always has a reference. So this is why we choose this. Where is it? Given to a reference level. This is what they're saying is reference height, 11. The change of the GPE equals to the negative work done by gravity. Again, this is another formula that they'll ask for later in like question 4 or 5, something like that. It's not on this list, but they ask for it once or twice. Okay, and now the body of GPE, the GPE of a body is proportional to its mass. GPE equals mgh. So the GPE is proportional to the m, to the g, and to the h. So this means that it's proportional to the height, it's proportional to the gravitational acceleration, and it's proportional to the mass. The GP of a proportion, that's not correct. That's closer to kinetic energy, and it is kinetic energy. So an increase in the GPE is equal to the work done on it by gravity. No, this is the actual one. So question 2. Question 2, simple. Question 2 is work equals force times distance times cosine theta. Now, an important note here is it says it's directed opposite to the displacement. And if the displacement horizontal, which in this case they'll always give horizontal, if it's directed with the displacement, it's going to be 0 because this is our force, right? It's going 0. It doesn't have a measure with the displacement. But if it's directed opposite, so let's say force was going this way, it would have a 180 degree to have a 180 degree measure for its theta. So W equals force times distance times cosine 180. So for cosine 180 is negative 1. So just remember it as negative FD. If you write cosine 180 on a calculator, it's fine. But preferably do it like this. Okay, so negative force times distance, so 3 times distance of 5. So 3 times 5 is 15 equals to negative 15. Now, this is about the work energy theorem. So delta KE, that's a triangle, delta KE is equal to the work. So delta KE, or the negative work done by gravity, sorry. But you don't need that now, never mind. The work energy theorem, this is something else. So let me just cross that out. Okay, there we go. Delta KE equals to W. So KE is half mv squared. That K is half mv squared. But I'll substitute the value straight away. M is 2. And v squared is v squared because it's unknown. Minus half of, again, the mass, mu squared. Mu is the initial velocity. So times 2 times u squared, and u would be initially moving at 10 seconds. So this would be ru. 10 squared all equals to negative 15. Now we could either do this on a calculator, or but some people don't have an equation solver, so I'm just gonna do this by hand. Half and half times 2, double the half is 1 basically, because it's gonna be 2 over 2. So this cancels with this, cancels the whole thing, and this half cancels with this 2. So what you have right now is v squared minus 100, because 10 squared is equal to negative 15. Just gonna move this up. So now you take the 100 to the other side, the key. V squared is equal to negative 15 plus 100, which is going to be 85. So v squared, so v is going to be root of 85, which we can do on a calculator. So I'm just going to go to the mouse, go to the calculator. Root of 85. Answer is 9.21. So v is equal to 9.21, but they want it to the nearest integer. So you round, and it's gonna be 9.2 is greater than less than 9.5, so you round down. It's gonna be 9 meters per second. And that's your answer. Question 3. A student of mass 40 kilograms stands for 50 stays, each of height 30 centimeters, use GS 10 meters per second. This is the reference point to our GPE. Like, this is what I meant by they'll ask it later. As chosen at the bottom of this quiz, the potential energy is the answer. Okay, so potential energy or GPE, I forgot to add the G. GPE equals to mgh. Now, the GPE, you can put it as PE, it doesn't matter, because in the end, he's going up. So the potential energy, this is a just the general relation, so it doesn't really matter. I'll erase the G. Potential energy is equal to mgh, potential, and so PE is equal to the mass, which is 40 times 10 times the height, which the height is going to be something different because the height here is given in 30 centimeters. We want it as meters. So what we're going to do is we're going to multiply 30 uh, by 10 to the power of negative 2 to make it, sorry, to make it into meters. Because, or actually, let me phrase this better. We're going to divide 30 by 100 to make it into meters. Centimeters to meters is 100, is the change factor is 100. So it's 50 times 30 over 100, which is going to be 0.3 equals, so we do this on a calculator. 50 times 0.3, gonna be 15. Okay, so what we're gonna do, we're gonna multiply all of this together. So we're gonna get here, I'm sorry, PE is equal to 400 times 15, which is gonna be, I'm sorry, I'm taking the calculator, I forgot to that, I need to show it. 40 times 15 times 10, or 400 times 15, doesn't really matter. It's gonna give us 6,000 joules. So now this, they want it in kilojoules though, this value. So again, a kilo is in is 1,000 normal unit, whatever the unit be, liter, milliliter, whatever, or sorry, liter, centimeter, whatever. So this is 6,000 over 1,000, which is 6 kilojoules. Now no, I don't really have time to explain the unit conversions really well, which is why I'm still explaining it really badly, because but you guys should already know this. So it's 6 kilojoules, and that's our answer. By the way, questions 2 and questions 3 are repeated as questions 19 and questions 20 in the quiz. Same question, same material, same given material, same everything. So I'm not gonna repeat the last two questions. I'll repeat one of them. I'll repeat question 19. In a given interaction, the work done by the gravity of, okay, this is an application of what we found in the first one here. GPE equals to negative delta WG. WG is the work done by gravity. So delta GPE, which doesn't really change by the way, because delta GPE is equal to the negative uh, WG, and GPE itself, the gravitational potential energy, is equal to the change in the inverse basically. I'm just gonna write them down to make your life easier. So you have this, and you also have this. You also have this. Both of these are valid, and so for example here we're gonna use delta GPE equals negative WG, but above we could that one was given. So we have we're not gonna use this one because they want the change in gravitational potential energy. So delta GPE. Delta GPE, so the negative work done by gravity. Now, the work done by gravity is negative 30 joules. So it's gonna be negative 30 joules. So negative and negative make the positive. So it's gonna be positive 30 joules. Again, because it's the negative of the value of the gravity done by the work done by gravity. So we go on to question 5. A box of mass 15 kilograms is lowered through 2.50 meters. Use G as 10 meters per second. Fill in the blank. The work done by gravity is blah blah blah. Okay. Question 5 here, and it's going to be much easier for me to explain it on the notes. The work done by gravity is mass times the gravity times by the height. Why? Because you don't need to know, but it's a long derivation. Your teacher should have explained, so I'm not going to go into it. Just memorize this formula. So the work done by gravity is equal to the m times the g times the h. So work done by gravity is equal to mass, which is 15 kilograms, times 10 times the height, which is 2.5. So 150 times 2.5 plus 15 times 10, which will be hopefully just 375, which is 375. Okay, so that's our answer. Moving on. By the way, I'm being quick because you guys want me to be quick. I'm listening to your guys' feedback. If you want me to be slow and explain in more detail, just tell me and I'll go back to explaining more and hopefully less. Yeah. A column crane lifts 320 kilograms of construction materials up floors 120 seconds. The height of each floor is 3.2 meters and G equals 10 meters per second. The power. Okay. So what you have to know here, power equals to W over T. Okay. The power is W. So the power is P, the work is W, and the T is time. So we start off with the work. We want to find the work. The work here is gonna be mgh because it's gravitational. It's going up, or yeah, it's going up. It's going up or down. Just it's probably gonna be mgh. It's going left or right. It's gonna be force times distance times cosine of theta. So W equals mgh. So the work equals to 320 times 10 times 12 times 3.2. So we're just gonna put that in brackets. So W equals 320 times 10, which is going to be 3200. If you see times 10, just add this. Just make it quick on yourself. Just add the zeros straight away. Don't spend extra time. 12 times 3.2. This equals this huge number. We're just gonna copy it down. 1, 2, 2, 8, 8, 0. Okay, and now this is gonna be divided by the time. So this is gonna be divided by 120, which is gonna be 1024 watts, which is our answer. So question 7. A ball of mass 1.20 kg moving vertically 2 meters above the ground. 5 seconds. We just move here to where are we? We are here. Okay. This one, it's an application of the mechanical energy. So the mechanical energy, ME or EM, I'm just going to use EM. On the notes, I used some ME, some EM. Doesn't matter, they're both the same. EM equals to the kinetic energy at a point, at like, let's say at point X, or we'll call it P, plus mechanical energy sorry, my brother came in. Over at point P. So the mechanical energy, we're gonna have to find the kinetic energy and the mechanical energy. So I'm just gonna go to the copy because this is gonna take a while. The potential energy is gonna be, oh sorry, this is potential energy. This is not mechanical energy. This is I made a mistake. Potential energy at point P. So first you want to find the potential energy, which is mass times gravity times height أكيد. 1.2 times 10 times 2, which is here 1.20 kilograms times 10 times 2. That's the height and that's the mass, and times that's the gravity, 24 joules. Now we find the kinetic energy, which is half mv squared. So half of the mass, which is 1.2, times the velocity, which I think was given as 5, because I put it as 5. Yeah, they give it as 5. 5 squared. Um, that's gonna equal to 15 joules. Let me just check my work. You can never be too sure. So what, 0.5 times 1.2 times 25, which is 15 joules. صح. Okay, so 15 plus 24 is 39 joules. Okay, question 8. A small ball is dropped out of a window 14.4 meters above the ground. Neglect air resistance, g 10 meters per second squared. The speed of the ball halfway through its fall. Okay, this is an application on the law of conservation of energy. So, mechanical energy, again, is equal to kinetic energy at point P and uh, uh, potential energy at point P. So, let's take point P to be the halfway point. So it's going to be KE. I'll call the halfway point H plus PE at the halfway point of H. Okay, but at the same time, mechanical energy also equals the maximal, like the kinetic energy at the maximum, uh, and so I'll call it the maximum M, and the minimum potential energy. So I'll call this the minimum as MI. Okay. Basically it's an inverse graph. So as our let's graph this. This is okay. So apparently, my audio corrupted for one of the clips. So I'm gonna have to redo from 8 to 15. Now I believe when I rewatched the clips, I started working on the graphs. So here's our two graphs. So we have the graph of potential energy versus kinetic energy. Now you can notice here that kinetic energy or potential energy is at the maximum when our kinetic energy is at the minimum. At the halfway point, which will be introduced later in the video, uh, is where they're equal to each other. And at when kinetic energy is at the maximum, potential energy is at the minimum. They're basically inverse unless they meet the halfway point. Again, these two add up to make the mechanical energy. So we take the points here and here. They equal the mechanical energy. So, the speed of the ball, let's go all the way back to question 8, which is here. Okay. The halfway point is introduced now, actually. So, halfway through its fall. Now, the halfway height, the height halfway is equal to 7.2. 14.4 divided by 2. Okay, let me just make sure if that's correct. 7.2 صح. Okay. Now, GPE equals MGH, you know that. Now, GPE initial is equal to the mechanical energy, or the mechanical energy, which is also equal to the kinetic energy at the minimum if it's the initial if it's the initial kinetic potential energy, gravitational potential energy, sorry. Um, it's equal to the kinetic energy at the minimum plus the gravitational potential energy at the maximum. This means that let me just make sure if this is correct. I wrote it in a different way here, but whatever. Uh, now you have your mechanical energy. Now mechanical energy, as I mentioned, at the halfway point, uh, the halfway point, it means that the KE and the potential energy, the gravitational potential energy, are equal. So let's go to the copybook. The initial potential energy is gonna be okay. I think I wrote something wrong here. Let me just make sure. Uh, yeah, no, I didn't write anything wrong. That's another question. I'm getting mixed up. Okay. So, the gravitational potential energy at the initial point is gonna be 14.4 times 14.4 times 10 times the mass, which is unknown. So it's gonna be 144 times the mass. So GPEI, just write it here, because 144 times the mass. The mass is unknown. So 144 equals to the kinetic energy. Let me just go to the copybook here. أحسن Physics 6. Let's uh, let's see. Yeah, okay. 144 is equal to the the kinetic energy plus the potential energy. So I'm gonna solve this in a different way. I did it in the copybook. Now we know these two are equal because they meet at the halfway point. I showed it to you graphically. So it's gonna be they want the kinetic energy, so we'll just say 2 ke. Okay. Now we find 1 ke, so 144 divided by 2, which is 72. So ke equals 72 Just move this up. So half mv squared uh mv squared is equal to 72 Now again we're gonna multiply by 2 on both sides to cancel out the fraction. So we multiply by 2 here and we multiply by 2 here. So the 2 cancels with the fraction. Mv squared equals to 144 equals now divide by mass to cancel the mass. So v squared equals 144. So v is root 144, which is 12 meters per second. That's our answer. Move on to question 9. A car mass of 1600, not speed. Okay, what do they want? They want the speed. So this is the work energy theorem. Delta delta ke is equal to W. So we find W. W is 800 times 100, which is 80,000. Okay, so half mass, which is 1600 times v squared minus notice it said accelerates from rest, so this is going to be minus 0 because you're going to have half mv squared mu squared. U would be the initial velocity, u is 0, so half of whatever, so the equation will cancel out to get 0. Minus 0 equals to 80,000. Okay, so 800 because half of 1600, 800 v squared equals to 80,000. Okay, now 80,000 divided by 800 cancels out the two zeros here and here. The 8 cancels with the 8 here. This becomes 1. This becomes 1. So v squared equals to 100. V is root 100, which is 10. Okay, moving on. Question 10. Okay, this is work equals mass times gravity times height. Now, I have a trick for you. If it's vertical, if the work they're talking about vertical here, it's WG. But if it's vertical work, I don't know if I said this before. I told you I did the video already. I forgot when I mentioned this note, but I did mention it. If the work is vertical, okay, it's gonna be MGH. If the work is horizontal, it's gonna be FD cosine theta. So Here the work is vertical, so we're gonna use mgh. So mass is 0.2 times 20 meters, but we won't take g first, so times 10 times 20. 0.2 times 10 times 20. 0.2 times 10 is 2. 2 times 20 is 40 joules. Okay, moving on. Question 11. Okay, here you're gonna want to think about this logically. Now, here it's obvious that its quantity is related to the work done by Earth on a falling body. So it's a body-Earth system, because you're concerned about the body and Earth. And it's the potential energies of these two, right? So obviously the potential energy on the body-Earth system is gonna be the potential energies of both of them. So the potential energy in the bottom and the potential energy of the Earth. Air resistance, ما دخله. Friction, not really related. Um, so it's you just think about it logically, really. It's step by step. What does a negative EP mean? I don't know if I mentioned this note, but if our object is going down, it's falling with the tendency of gravity. Okay, so gravity wants to go down. That means that the work done by gravity is positive, which means that the delta EP is negative. Now, if the body is moving up, so let's say if the body is up, this is going against the tendency of gravity, and obviously the object is gaining more potential energy and it's going up. So, the work done by gravity here, since it's resisting gravity, is gonna be negative. And the delta EP is gonna be this is negative. Delta EP is gonna be positive. Okay, so here they're telling you negative delta EP. So that means the body is moving down. It's going with the gravity. Again, these two are inverse. I believe question 1 or question 3, something like that. I explained this. A toy car is projected across a rough floor. Let me just check if I'm recording my audio this time. Yes, I am. Beautiful. A toy car is projected across a rough floor. As a result, the kinetic energy, okay, it's 5 meters. The initial kinetic energy of the car is 4 joules. Okay. So immediately once you have kinetic energy, think of the work energy theorem. So delta KE or delta EK is equal to work. So what you're gonna want to do? You want to find the delta KE, half mv squared, which do we know what it is? How it's the mass? No, we don't. Okay. But I realized here they gave you initial. So delta EK is equal to the final kinetic energy minus the initial, which is 4. Okay. To find the kinetic energy final, they told you it's projected across a rough floor. The kinetic energy is halved over a distance of 5 meters. So if it's halved, that means that the final kinetic energy is half of the initial, since the kinetic energy is half the final. So EKF is half of EKI. I is the initial, and EKI is 4 joules. So half of 4 is going to be 2. So instead of we substitute this here, delta EK equals to 2 minus 4, which equals to negative 2. And this is the answer to part A, because again, delta EK equals to the work. Okay, the magnitude of friction. Now, work is force times distance cosine theta. But since we already have the work to be negative, cosine theta was already applied. Force times distance. Force, it's not given, so we'll label it F times 5, because the distance is 5 meters. So to get rid of to keep F, we're gonna divide by 5. This cancels. F equals to negative 2 over 5, which equals to negative 0.4. But they want the magnitude, and remember the magnitude means that they only want the scalar quantity, so so it's gonna be positive. which means that our answer is positive. If they just said what is the force done by the friction, write negative 0.4, because then they're indicating that it's the vector, not the scalar. Okay, question 14. Okay, where are we? We're on 8. No, we need to go down to 14. Okay, so the work done by gravity, again, it's mgh. So mass, which is 0.2 times 10 times 8. Okay, 0.2 times 10 is 2. 2 times 8 is 16. So A is 16. Now, according to the work energy theorem, the kinetic energy of the ball is at about to the ground. So KEF delta EK, خلاص, just delta KE, doesn't matter, equals to the work. The initial kinetic energy. We're just gonna go to a couple of notes. It's gonna be too long to write. This, ignore this. I took it. I'll take it to the other side either way, but I would take it at the end. I took it from the start. I don't know why. Okay. So delta EK, so KEF minus KEI equals to 16. Okay. Half of mv squared point 2 v squared. Actually, you don't need this now. You're gonna need it in part C. Just go here. So 60 plus KEI. KEI is half of mu squared. Did they give us the initial? They did not. Where is it? No, they did give us the initial. My bad. It's projected at 10 meters per second. It is given at the initial. V squared. So we're just gonna keep this as KEF now because we're gonna solve for it later. KEF minus half of 0.2 10 squared, which is 100, equals to 16. Half of 0.2 0.1. 0.1 times 100 is gonna be 10. So KEF minus 10 is equal to 16. Take 10 to the other side. KEF is going to be equal to 26 joules because 16 plus 10. Now, keep in mind, the way I mentioned earlier with this, the half mv squared will work. يعني بالآخر here it equals to the final kinetic energy. But to simplify, لأنه you're gonna find the velocity, the final part. Keep it as final kinetic energy. يعني it doesn't matter. I can use half of mv squared. It's gonna make it so complicated. So the speed of the ball as it hits the ground to the nearest integer. Now we solve for the velocity. So half of mv squared, which is 0.2, 0.1. So half of 0.2, 0.1. So I'll just write it 0.1 times v squared equals to 26. Okay. 0.26. So you divide by 0.1. Okay. So v squared is equal to 26 divided by 0.1. I'm showing you a different way than the PDF, so you know you have more than one way of solving this. 26 divided by 0.1, 260. So v squared is 260. Root v squared. Root v squared is gonna be v is 16. 16.12 to the nearest integer, so 16 meters per second. Okay. Question 15. I think I did explain it in the other clip. لأنه I separated the clip, so I deleted the clip that's corrupted. So anyways, يلا keep good luck guys. Hopefully you make it to the end of the video. If you do, thank you so much. Just keep watching to repeat the question from the start, I guess. So they said that they took the first point as reference, so which means that it's gonna be GPE equals to mg delta H. Delta H because you didn't take the reference as the ground floor. You took it as the first floor. Once you have a reference above 0 meters, in this case it's 4, but don't consider it like that. Once you have anything above the ground floor, take it as delta H. So let's solve part B first, because part B is the easiest. GPE of the worker standing on the first floor, so it's gonna be 90 kilos times the first floor, 90 kilos times 4, no, not times 4, sorry, times 10 times 0, because again we took the first point before, took the first floor as reference, and he's standing on the first floor. So the height difference between the first floor and the first floor is 0 meters. So this is gonna be 0. Okay, and now we solve part A. He is under the reference by 4 meters. So it's gonna be 90 times 10 times negative 4. I'm just gonna show it here. 90 times 10 times negative 4, negative 3,600 joules. And I want it in kilojoules, so divide by 1,000, negative 3.6. Now, the work is standing on the third floor. Third floor, it would be 4 times 12, as 4 times 3, which is 12. If it was on the reference as the ground floor, but the reference is on the first floor. So it's gonna be, let's take the, we do it mathematically. Let's do second floor here. So it's 4 meters up here. This is 4. And this is 4. So this is gonna be 8. So GPE is equal to 90 times 10 times 8, which is going to be 7,200, if I'm correct. 7,200, which simplifies into 7.2 kilojoules. Okay. A pump is used to lift 200 kilos of water by the height of 6 meters in 2.5 minutes. Use G as 10 meters per second. The work done. Work is W equals FD. I'll just go to the copy box straight away. Okay, equals FD, but wait, it's by the height. Oh, okay. So this is gonna be work done by gravity. I didn't take the question, sorry. Work done by gravity against gravity means that it's the negative work done by gravity. So, oh my god, I overcomplicated the question. Ignore what I said. The work is mgh if it's vertical. I gave you the note. If it's vertical, use mgh. Okay, so 200 mass is 200, the height is 6, and you don't need the time. But wait, why do we don't have the force? MGH, we don't need it, never mind. The height 200 times 10 times 6, 200 times 10 is 2,000, 2,000 times 6 is 12,000. They want it in kilojoules, so cross 3 zeros out because you're dividing by 1,000, 12 kilojoules. Okay, I'm sorry if I overcomplicated the question. Just remember, vertical, it's gonna be MGH for work, and horizontal is gonna be FD cosine theta. Okay. So we did the first part, which came to 12 kilojoules. The power. Power is worked over time. So 12,000 over 2.50 minutes. So 2 minutes and 30 seconds. 2 minutes is 120 seconds. 120 plus 30, 150 seconds. So you divide this 12,000 divided by 150. 80 watts. Okay, that's your answer. Question 17. Same thing, but this time it's horizontal. So we do FD. So 5 times 5,000, sorry, it's kilonewtons. 5,000 newtons times distance, 880 meters. Cosine theta, but it's along the horizontal road, not against it. So it's going to be cosine of 0, which is 1. So this is going to equal, I believe 4.4 million or something like that. I don't remember. So 5,000 times 880. This huge number. I'm not gonna bother. Now, a megajoule means that it's mega, so times 10 to the power of negative 6. So times 1 over negative 6 means 1 over 10 to the power of 6. I know sometimes the calculator won't let you do times 10 to the power of negative 6 with the answer. 4.4. Okay. The power by the crane, it's that huge number. So I believe you can use this. So, where are we? We are not in this question. We are here. 44 times 10 to the power of 5, which is our first answer. 44 times 10 to the power of 5 over 80, which equals to, let's calculate this. 10 to the power of 5 over 80, 55,000. 55,000, now they want kilowatts. So 55,000 divided by 1,000, which means you just cross out the 3 zeros. 55. Okay. Question 18. A car is moving at a... Okay, this is that only question. Basically, this one's gonna take a while to solve. Okay, this is an application of like 3 laws at once. So potential energy, here, I'm a block of mass equals 2 of mass 2 kilos, slides from the rest down a smooth inclined plane. The elevation of the inclined plane is 3.2 meters, as shown in the diagram below. Take 10 meters per second for reference, and the gravitational potential energy at the bottom of the inclined plane. Okay. The speed at the block. So, PE equals mgh. Okay, do you want to solve for potential energy because you want to apply the mechanical energy rule at this time. So, P equals mgh. Potential energy is 2 times 10 times 3.2. لأنه the mass is 3.2, the height is 3.2, sorry. So 20 times 3.2, 64. Mechanical energy is potential energy plus kinetic energy. Okay. I explained this before. The mechanical energy at the highest point is the potential energy at the maximal point, and the kinetic energy at the minimal point. By the law of conservation of energy, the kinetic energy at the maximum is equal to the potential energy at the minimum, and the kinetic energy at the minimum equals the potential energy of the maximum. The inverse, basically. Remember it. Refer to the graph I gave you before. Mechanical energy at the highest point is 64 joules. And we found it to be, this is the potential energy at the maximum point. I know the height is 3.2. So that's our maximum point. Okay. And now 64, because the mechanical energy is always conserved. 64 equals to the kinetic energy at the maximum point plus the potential energy at the minimum point. Now you can see that they told you the reference is at the bottom of the inclined plane. The bottom of the inclined plane, that's our gravitational potential energy. That means the minimum is 0 because it's at the bottom. Our reference is always 0. So it's gonna be the maximum kinetic energy plus 0. So so equals to 64. So 64 is just equal to the, as you can see, potential energy minimum 0 meters times 0. So the kinetic energy maximum at the lowest point is equal to 64. So half v squared times the mass, which is 2, is equal to 64. So this is obviously to find the maximum kinetic energy. So the half cancels with the 2. V squared equals 64. V equals 8. Okay. If I cut one more time. Where was I? I think I solved this. I'm positive I solved this. So choose the correct answer. The speed of the block after sliding down inclined plane A is equal to the speed of the block E. No, it's the same conditions. This is also 3.2 meters. They said that the inclined plane is 3.2 meters. Or these two are the same height. And if you take them like this, same height. So 3.2 meters, 3.2 meters. It's the same block. So, and obviously G is constant. So M is the same and the height is the same. Same conditions. يعني the speed will remain the same. You're gonna apply basically what you applied at the inclined plane A to inclined plane B. You're gonna find the same speed. But the power is done by the power done by gravity while sliding down block A uh, is smaller than the power developed by the gravity on the block, because here you have a shorter distance, so gravity acts more. Here your distance is smaller, the gravity is gonna act faster. Here, unlike here, it's gonna take this long arrow, it's just gonna take this short arrow, so that's why it's smaller. Okay, so question 19. Wasn't question 19 a repeat of question 2? Let me just check. Or no, this was yeah, this was a repeat of question 3, and this was a repeat of question 2 or question 3, whatever. The last two questions are repeated. I'm not gonna cover them. You can rewatch my explanation on 2 and 3. See, I got it wrong لأنه I wrote 9 point something. I didn't see the used integer. And here it's the same question, same exact question. So if you want to rewatch, you can rewatch. Thank you guys. يلا, good luck.